this before we start, let's just enjoy this.
Well, I'm recording right now, so we can put that. You can put your comment in. No, this is too calming. It needs to be more
intense,
twangy.
Twangy?
Yeah.
Do you have any recommendations? I do.
No, get some saxophone or something. Welcome to Math with Lily.
Where does the critical point classification formula come from?
I don't know. Good thing we have this video in front of us that suddenly appeared.
D1, D2, negative f sub xy, max, min, saddle?
I have no idea how I'm going to stitch this together.
Why is it moving up and down?
I don't know, but we gotta have to find a way to classify.
That looks like a horse saddle, wow.
Alright, so we want to figure out whether our critical point is a max, min, or saddle. We know if it's a max. What will our approximation look like, Emily?
Well,
That.
I think you need to tell me. Oh, shit.
If it's a min, the quadratic approximation will face upward.
Oh yeah, that looks like a minimum.
That definitely looks like a min.
But it's 3D this time.
Yeah. So what other possibility is there other than max or min?
Well, right there it says saddle. Could that be it?
I think so.
Is that a saddle?
Looks like a saddle.
Yeah, I guess.
So how do we figure out if it's a max, min, or saddle?
Slicing?
Oh, that's a good idea, actually.
Is that true?
Yeah. Because if you slice it, depending on what the slices look like, that's going to tell you what kind of approximation.
Is that how you slice it?
That is a way you could.
Is that the way we're going to slice it?
That is the way we're going to slice it.
Why?
Because it's easy to do it along the y-axis or along the x-axis.
Okay.
Well, first we need our formula for the quadratic approximation.
That's a lot of things.
It's definitely a lot of things. Well, the first part's easy. It's just the point, our critical point. But the second term is messy, and that tells us how our approximation works as we move away from our point. Well, what's that second term going to be if we have a min?
A min?
Yeah.
Oh. And
It'll
if
be
we have
positive.
Oh, okay, yeah.
And if it's max, we have to be negative because we're moving down as we move away from the point.
Mm-hmm.
But if it's a saddle, we can go down or we can go up. Let's make the messiness go away. Replace, replace, replace.
Smooth.
Now we got a simple quadratic. Simple enough.
Are
Simpler.
quadratics really ever simple?
It's simpler, see? So now we're asking whether...
We're chasing the question.
Oh, we're
up.
chasing the question. See, this is way too many
Is
words.
this quadratic always positive, always negative?
See, too many words.
So
Should
what's
have
really going on
animated it slower. Oh, we're using the quadratic
That's
formula.
not the one I know.
It's a different quadratic formula.
Wait, what's that?
That's the determinant.
Okay, so we focus in on the determinant and apply it.
Mm-hmm.
We find the determinant.
Yeah, we find the determinant.
And then what do we do?
Well, if the determinant is positive, that means we have roots. But if it's negative, there's no roots. And if there's negative, then our quadratic slices might look like this.
Oh.
And they never cross the x-axis. See, it never crosses the x-axis. That's because our determinant is negative. And that means we got a min. Because it never crosses over. Or...
And it goes...
This one also never crosses over.
Oh, that's a max!
And
Because
that's
it
a max.
increases and then decreases.
Yep, our slicer.
Just like in 2D because we sliced it.
We're sliced it in one direction so we can work with 2D kind
We
of
used
stuff.
to slice the 2D versions in high school, huh? Wait, what's going on here?
Well, if it's positive, then the slices cross over the axis. And that makes us have a saddle. So you see here, see the parabola crossing over? Crosses over the axis and then comes
just
back.
Barely though.
Barely. Well, it doesn't matter. If it does at all, we're going to have a saddle.
Interesting.
So see, this is kind of like what it would look like. You see that parabola crossing over the midline.
Yeah.
So, in summary,
We
these
have
formulas.
saddles, maxes, and wait for it. Oh, the min already happened. So what is a max, min, and saddle? We've learned that a max is a critical point that is the local maximum. A min is a critical point that's the local minimum, which means it's the bottommost point of the 3D plane. And a saddle means that depending on where you approach from, it could be a min or a max.
That's right, Leilani.
Could it be both?
Kind of like neither.
Wow.
Wow.
Makes sense.
That sounds like a homework Omega project.
It's calm.
Boom, bada bing, bada boom. You got yourself a project.